example 11 says if alpha and beta are the roots of the equation 2x squared minus 5x minus 4 equals 0, find the quadratic equation with the given roots alpha over beta and beta over alpha. So what we're going to do here is we're going to go ahead and build our equation, and then we're going to work our way down to where we can find all the remaining information that we need. So we start off, the equation that we're looking for, okay, has these roots. And so we know that we're going to have, we'll leave x squared. We know that if this is the case, right, the sum of our these two roots are going to show up right here. And so we're going to have alpha over beta plus beta over alpha times x. So, like what we saw in the last example, the sum of our roots can show up here, but it's the opposite of their sum. And then we're going to have the product of the two roots is going to be what's left over. And so what the product of those that's left over is going to be alpha over beta times times beta over alpha. And that's going to equal 0. So what we want to try to do now is try to simplify this as best we can. We will see that x squared minus, now if we do alpha over beta plus beta over alpha, we're going to use our little algorithm we learned earlier. So we do, we multiply down, so we get alpha squared, sign in the middle, plus beta squared over alpha beta. So that is kind of simplified down, and we still have those amount of x's. And we're going to add in alpha over beta times beta over alpha. Well, these naturally just cancel each other out. We're just left with 1. So all we have to deal with is this yellow part here, and if we find our yellow part, we're going to be finished. And so let me scroll down. And so at this point, only thing we don't know is alpha squared plus beta squared, but remember we had this note earlier. Remember we said that alpha plus beta squared is going to give us alpha squared plus 2 alpha beta plus beta squared. And so we found ultimately that we had alpha plus beta squared minus 2ab, or 2 alpha beta, equals our alpha squared plus beta squared. So we can go ahead and kind of replace that in our equation. So we're going to do that here. We're going to have x squared minus, okay, let's see here. This is going to be alpha plus beta squared minus 2 alpha beta divided by alpha beta. We have that number of x's, okay, and so plus 1 equals 0. So all of these things that we know, all of these things that we can go and find and replace. So now what we need to do is figure out in the original equation, what would alpha plus beta and what would beta and alpha times beta be. So if we look at our original equation, alpha plus beta is supposed to be the opposite of b, so we had negative 5 over 2, which is just 5 halves. So we can replace alpha plus beta with 5 halves. And we also know that alpha times beta is going to equal negative 4 over 2, which is negative 2. So we're going to use 5 halves for alpha plus beta and negative 2 for alpha times. So we go down here. We're going to say, okay, so we got x squared minus, so alpha plus beta we had was 5 halves. So we have 5 halves squared minus 2 times negative 2, because that was what alpha beta was. And we divide by alpha beta, which is -2. And now all we really need to do is just simplify, and we are finished. So we have x squared minus, so 5 halves squared is 25 fourths. And then we have plus 4, all divided by -2. And we close by trying to simplify this. So we have 25 fourths plus 4. So 4 is 16 fourths, so this is 41 over 4 over -2. And so now what we're going to get is these negatives will kind of cancel each other. So we divide by 2, we're going to get plus 41 over 8 x plus 1 equals 0. So very interesting equation. And it asked us to do integral coefficients as well. So what we're going to go ahead and do is multiply everything by 8. And so we would end up with 8x squared plus 41x plus 8. So that is a challenging problem, but again, we're using algebraic manipulation and using what we know about how we can build equations in order to get all of this stuff together.